We have another particle velocity acceleration problem here. So there's all my work and my answers. So if you just need to check certain things there or skip to a certain part of the video, you're welcome to do that. But here they give us the velocity of particle P and the velocity of particle Q. And so what I got in my graphing calculator, I graphed both of those in my graphing calculator already. So that's like my Y1 and my Y2 there. And anytime there's trig involved, I like to hit the zoom 7. And then after that, it told us it was in between 0 and pi. So I hit my window button and I made that in between the 0 and the pi key right there. All right, so for part A, it says find the position. So we know to go from velocity to position, we're going to integrate those velocities, right? But you always have to take into account the initial position. So if I want to find the position at time t equals 1, notice they told us at time t equals 0, where the particle P was at and where the particle Q was at. So you got to start with that, and then you integrate in between 0 and 1. So basically, to find the position at 1 for both of these, I'm going to do the initial position at times t equals 0, which is what they gave us, the 5 and the 10. And I'm going to do the integral between 0 and 1 of the velocity for particle P and the velocity for particle Q. So that'll tell us where we went in that first second, and this will take into account that initial position right there. So since I already have those in my graphing calculator, that means I can just go ahead and I'm going to hit that 5 plus in there right away. And then when I hit my math 9, I'm going to go between 0 and 1. And then I'm just going to hit in my alpha trace. And then there's my Y1, since I already have that entered into the graphing calculator, and that's going to give me my 5.371 number, okay? Same thing on the next one, I could go 10 plus, and I can hit the math 9, and since I already have the particle Q velocity in there, I can just hit alpha trace, and that's my Y2. That's the second equation I graphed, and my Y equals, and then that's going to give me my 8.564 number right there. So as long as you remember to take into account that initial position, you're going to be good with those. And so we have both of those positions for part A. Now for part B, I thought part C and part D was actually the easiest parts of this problem right there. Part B, I had to think for a little bit on this one. It says as particles P and Q moving toward each other or away from each other at time t equals 1. Now, if you want to know, it says they're only moving along the x-axis. So if I have a positive velocity, I'm going to the right. Negative velocity, we're going to be going to the left there. So you want to know if they're going to the right or to the left, you want to figure out what the velocities are at those times. So I already had, like I said, the velocity 1 for particle P and the velocity particle Q in this graphing calculator. So once I have those in there, I could just go to the graph then. I can hit the trace button. That's my equation for particle P, and I could just type in 1, and it gives me the 0.841. So right there, that tells me the velocity of particle P is positive. So if the velocity is positive, that means the first derivative is positive. That means that function is going to be going in that positive direction, going to the right. And then the same thing, then I just hit the down arrow. There's my equation for particle Q. I already got the trace button selected there. Now I can type in 1. That is the velocity function of particle Q, and I got a negative number for that. So that tells me, since the derivative, the velocity is negative, that particle is moving to the left. Now, what I then thought about, I said, okay, at 1 second there, the particle is moving to the right, to the left. And then I had to figure out, okay, where were they at those times? So that's why I kind of use those positions. This is where we're at t equals 1. That particle P was there, and the velocity was positive, was going to the right. And then particle Q is at this 8.5 number, and then that velocity was negative, so it was going to the left. So since they were like on this side of each other and then going to the right and to the left, they're moving towards each other. That's what I got for that final answer right there. So I guess I was just kind of thinking if this particle would have been on this side of it and going that way and that way, then when they would have been going away from each other there. So that's what I just kind of drew that little picture to kind of help myself right there. But there I had to think a little bit on that part B. And then part C and D, this is stuff that we've seen before, and we should know how to approach these things there. So when it tells us to find the acceleration of particle Q, the order goes position, velocity, acceleration. And so to get to the acceleration, we need to do the derivative of that velocity Q. So I already have the velocity Q in my graphing calculator. And if this is the graphing calculator problem there. So instead of taking the derivative of this ourselves and doing a product rule and doing all those derivatives there and plugging in, remember the math 8 feature on the calculator will take the derivative of that for us there. So since I already have this in as my second equation, that's my y2, I'm going to go to my main screen and I'm going to do the math 8. That's going to take the derivative for me of that function there. So I'm going to hit my alpha trace. There's my y2, that's particle q. And then it says at time t equals 1. So I enter in that number right there. And that's how I'm getting this 1.027 number. So that's the first part of it, is they wanted that acceleration. The next part, it says, is the speed of particle q increasing or decreasing at that time? So remember from our main study guide, our blue packet, speed is increasing, the velocity and acceleration have the same sign. Speed is decreasing, the velocity and acceleration have opposite signs. So since I already knew what the acceleration was, I did the math 8 to get the acceleration was a positive number. We also already know from part B that the velocity of particle q is a negative number. And if I didn't know that from part B, I have the velocity function in there. So I can hit the trace button, go to particle q and type in 1. It tells me what that velocity is. And so I have, if you always, whenever they talk about speed, you need to get the sign of the acceleration and velocity. If they're the same sign, the speed is going to be increasing. But since these are opposite signs, that's, you have to justify that. It says explain your reasoning. So they want to hear the speed of particle q is decreasing since the velocity and acceleration have opposite signs. For part D, easy calculator problem there, but you got to make sure you're showing your setups, okay? Show your setups for these things. That way, if you happen to bump something wrong on the calculator, you can get some credit for that. When it tells us total distance traveled, that is in your blue packet. You got the displacement formula, you got the total distance traveled formula right there. I want the total distance traveled. That's the integral of the absolute value of that velocity. And this time we're talking about particle P. And so I can just enter that then into my calculator. We could do the math 9. And I can go between the 0 and the pi real quick. And I want the absolute value. So remember, hit the math button, go over to the right where it says number, NUM. I'm going to highlight number 1, hit enter on that, brings up the absolute value. And then my velocity P is my y1 that I have in here. So I just say I'd hit alpha trace, type in that y1 button, and then it calculates that number for you, okay? But you need to show the setup of that integral. It's taking a little minute, but it'll get there. But you need to show the setup, okay? There's your 1.931. Always round to 3 numbers after the decimal and show the setups of your integral before you use that graphing calculator. Elephants.